Scholars and parents, this is the video that accompanies homework 5.21. However, I'm not going to do any part of the homework today because this homework is to prepare you for the unit assessment, and I want you to be able to practice all of the different problem types on your own. So instead, what I'm going to do is I am going to walk through the answers to the CR packet from 5.21. It goes through all of the different problem types, and so you'll have an example for each of the homeworks. You just have to use your knowledge to match up which example goes with which question. And one quick plug, in order to be ready for the unit assessment on Monday, you must be able to solve all of the questions in the homework. So if you are unsure about any of the questions, ask your family for help, and if they don't know, ask your teachers. Call us over the weekend. You must be ready for the unit assessment. Here we go. I'm going to go through the entire independent practice section. If at any point you feel like you're ready to go on and do your homework, go ahead. First question is, Savannah drinks half the water in her bottle. The water bottle had 1/3 of a gallon in it. How much water did she drink? The important thing is that you can always come up with the right picture, and that your picture should be able to show you your answer. You shouldn't have to do any math. So in this case, I start with 1/3 of a gallon, and then I take half of that and I drink it. So first I drew 1/3 going in this direction. I shaded 1/3 and I labeled it at the bottom. And then I cut it in half in the other direction. I labeled it 1/2. And the overlapping section is this circle. This is 1 out of 1, 2, 3, 4, 5, 6. Answer is 1/6. In this case, this example, Jamie has a dog named Chance. Chance eats 1 2/5 cups of food each day. How much food does Chance eat in a week? In this case, we have repeated addition happening because we have a dog eating food, the same amount of food every day for 7 days. So each of my fraction strips represents the amount of food the dog eats on one day, and then I get my answer just by adding them all together. So I have 1 2/5, 1 2/5, 1 2/5, and so on. And I labeled this one. This is day 1, day 2, day 3, day 4, day 5, day 6, day 7. The equation that goes with this is 7 times 1 2/5. I didn't give an equation that goes with this. This one is 1/3 times 1/2, or 1/3 divided by 2. Number 3, Amanda is cutting pieces of blue fabric that are 3/4 of a foot long. If she has 7 feet of fabric, how many 3/4 foot long pieces can she cut? I misread the problem. I apologize. They're 1/4 pieces. So she starts with 7 feet of fabric. She's cutting them into pieces, and each piece is 1/4. So I started by drawing 7 holes, 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, 6 foot, 7 feet. And I cut each of them into 4 pieces. Each of these pieces has a value of 1/4. And each foot of yarn can make 4 pieces. So I'm going to be able to get my answer by counting up the number of slices. I am not shading any of these because if I shaded, that would tell me just to count the shaded ones. And in this case, I want to know the total number of pieces she can make. She has all 7, so I want to know the total amount. If you wanted to shade, you would have to shade in every single piece of the fraction strip. The equation for this type of problem is 7 divided by 1/4, or 7 times 4. Let me write that down. 7 divided by 1/4. Okay, next question. Destiny has half a gallon of soda. She needs to pour 6 glasses of soda. What fraction of a gallon should she put in each glass? Here, this is a classic. We start with half a gallon. We split it into glasses. So I started by drawing my half gallon and I shaded it in. I labeled at the bottom. And then I split it into glasses. 1 glass, 2 glass, 3, 4, 5, 6 glasses. I only care about how much orange juice or soda is in 1 glass, so I circled 1 at the top. My answer is going to be 1 out of 12, which is the total number of pieces in my whole. And the problem, the equation for this one, would be 1/2 divided by 6, or 1/2 times 1/6. Next question. There are 4 walls in the auditorium. Scholars are working together to cover 5/6 of each wall with decorations for an end-of-year party. What fraction of the walls will they cover in total? So we start with 4 walls. For each of the wall, we're going to cover 5/6 of it. So let's draw that. I started by drawing 4 boxes for my 4 fraction strips, and then I cut them into 6 pieces because that's my denominator, and I shaded 5/6. This is the amount of wall that is covered in each case, and I can get my answer just by counting them up. The equation for this problem is 4 times 5/6. The next one. 5 students want to share 6 cookies equally. How much cookie will each student get? We start with 6 cookies, and then we're going to divide it into 5 groups to share with the 5 students. So I started by drawing just 6 open boxes. I didn't have any cuts in it yet. And then I put my groups down at the bottom. I had 5 groups. Group 1, 2, 3, 4, 5. And I could tell that 6 wasn't going to go into 5 nicely, or 5 wasn't going to go into 6 nicely. So I broke up each of the cookies into 5 pieces. So this one person is going to get 1 piece from this cookie, 1 piece from this cookie, 1 piece from this cookie, 1 piece from that, 1 piece from that, and 1 piece from that. So this person, group 1, is going to get 6 pieces. And each piece, each of these one single pieces, has a value of 1/5 of a cookie. So each scholar will get 6/5 of a cookie. The equation for this is 6 divided by 5. Next question. One day at McDonald's, 1/3 of all customers ordered breakfast sandwiches. Half of the breakfast sandwiches had bacon. What fraction of all customers ordered a breakfast sandwich with bacon? So first, I start with 1/3 of the customers. So I shaded in 1/3. This represents the amount of customers who ordered breakfast sandwiches. Then only half of those customers ordered breakfast sandwiches with bacon. So I shaded half in this direction and I labeled it. This is the overlapping section. So the answer is that 1 out of 6 customers ordered a breakfast sandwich with bacon. This would be 1/3 times 1/2, or 1/3 divided by 2. Next question. Jacqueline and her friends went to the store to buy 1/5 of a pound of candy. If they split it evenly, how much candy did each friend get? In this case, we start with 1/5 of a pound of candy. Then we divide it into 4 sections, 4 groups, 4 friends. So I started by drawing 1/5, 1, I shaded the 1 out of 5, and then I divided it in the other direction into friend 1, friend 2, friend 3, and friend 4. I only care about what one friend gets, so I circled just friend 1. Friend 1 is going to get 1 out of 1, 2, 3, 4. I know there's 5 going in that direction, so 1 out of 20. The equation for this type of problem is 1/5 times 1/4, or 1/5 divided by 4. Ms. Sissoko has 6 bags of chocolate chips. It takes 1/5 of a bag to make a batch of chocolate chips. To make 1 batch of cookies. How many batches of cookies can she bake? So we start with 6 bags of chocolate chips. We know that she can make 5 batches with each bag. So we're dividing them into 1/5 pieces. Each of these bags, so bag of chocolate chips, bag of chocolate chips, chocolate chips, chocolate chips, chocolate chips, chocolate chips. Because it takes her 1/5 of the bag to make 1 batch, that means she can make 5 batches with 1 bag. So each section of my fraction strip represents 1 batch of cookies. I can get my total answer just by counting up the number of sections, because each of those sections is a batch. The equation for this type of problem is 6 divided by 1/5, or 6 times 5. Number 10. A race that is 10 miles long has a flag every half mile. How many flags are there in the race? So we're starting with 10 miles. The race is 10 miles long. I drew 10 fraction strips to represent the 10 miles. Then every half mile, there's a flag. So I divided each of my miles in half. And I actually thought about it this way. So if I start here and I go half a mile, here's a flag. Then I go another half a mile, here's a flag. Maybe it would have been easier if I'd kept them together, because now I'm jumping and go another half mile, here's a flag. Another half mile, here's a flag. Another half mile, here's a flag. So I just keep counting up. Every half mile, I'm going to hit another flag. And ultimately, each of these halves has a flag in it. So it becomes 10 times 2. The other way that you could write an equation for this question is 10 divided by 1/2. Last page. Mr. Vasquez had 2/3 of an apple pie left over after his family reunion over the weekend. His sons ate 3/7 of the leftover pie. What fraction of the whole pie did his sons eat? What do you start with? We start with part of the pie. We start with 2/3 of the pie. Then we eat 3/7 of that 2/3. We don't eat 3/7 of the pie, we eat 3/7 of what was left. So I started by drawing the 2/3 in this direction, and then I broke it into sevenths in the other direction. I shaded 2/3 here, and I shaded 3/7 here, and I put a box around the double shaded section. I can count that up, 1, 2, 3, 4, 5, 6, and it's out of 21 because I have 3 going this way and I have 7 going this way. We can see that just from this right here. 3 times 2 is going to give us 6. 7 times 3 would give us 21. And that is the equation for this type of problem. You multiply the two fractions. Last question. 6 scholars want to share 4 2/4 bags of popcorn. How much popcorn would each scholar get? Start with 4 2/4 bags, then we break it into 6 groups for 6 scholars. So I started by drawing what I have. I have 1, 2, 3, 4 holes and 2/4. That's my popcorn. Down here are my scholars. Broke them into groups. Each of these sections represents a 4th. So I'm going to try to just separate my sections out into my groups and see what I get. Here's a way to think about it. I have 4, 8, 12, 16, 17, 18 fourths. Since each of these is 1/4, and I have 18 of them, I have 18 fourths. 18 divided by 6 is 3. So I'm going to end up with 3/4 in each group. The equation for this problem is 4 2/4 divided by 6. So scholars, at this time, you should be using your packet from class and checking your work against what I did. If you have questions, please do call, particularly with your equations. So I'm actually going to go back right now and I'm going to write down the equations for each question. We didn't do that in class because in class we were working on getting the right visual, and the right visual is the most important thing. If you have the right visual, a visual that really represents the problem, then you can get your answer just by looking at the picture. But I also want you to be able to connect it to the equations because some of the questions on the test may just have equations. So the first one was, the first example, we're talking about juice. We had 1/3 times 1/2. The next one was 7 times 1 2/5. Question number 3, 7 divided by 4. Question number 4, 1/2 divided by 6. Question number 5, 4 times 5/6. Question number 7, I'm sorry, that was 5, so this is 6, is 6 divided by 5, 6 cookies divided by 5 students. Question number 7, we had 1/3 customers times half the breakfast sandwiches. 1/3 times 1/2 could also be written 1/3 divided by 2. Next question, this is 1/5 divided by 4, or 1/5 times 1/4. Next question is 6 divided by 1/5, or 6 times 5. So we had chocolate chips. We were making batches of cookies. We can make 5 batches per bag of chocolate chips. The next one was 10 divided by 1/2, or 10 times 2. 10 miles, flags every half mile. Two-thirds times 3/7. We're talking about pi. And finally, 4 2/4 divided by 6. Okay. Please make sure that you understand this completely and that you're able to do all of the homework. If you are not sure, give us a call. My phone number is 313-418-1482. Good luck.